Imagine, if you will, the ability to leap through time, to traverse the vast expanse of the past and future. Would you change the past, or perhaps glimpse into the future? But what if your actions create a paradox that defies the laws of reality? This is the fundamental enigma of time travel paradoxes. Consider, for instance, the grandfather paradox, a theory that poses intriguing questions about the consequences of time travel. The concept is simple, yet mind-boggling. You travel in time and inadvertently prevent your grandfather from meeting your grandmother. This could mean your very existence is at stake, as your birth might not occur at all. But if you were never born, then how could you have traveled back in time to alter the past in the first? This cyclical dilemma epitomizes the paradox, defying our understanding of cause and effect. Ultimately, the grandfather paradox posits that any action that prevents your birth would retroactively erase your ability to enact that action. This not only challenges our comprehension of time, but also blurs the lines between and impossibility, raising compelling questions about the nature of existence itself. Welcome to the labyrinthine world of time travel paradoxes, where each step could potentially rewrite your existence. Next, we plunge deeper into the enigmatic Bootstrap Paradox. This is a perplexing loop where objects or information appear to exist without ever having originated. It's a causal loop that really challenges our understanding of cause and effect. Let's consider a more concrete example. Imagine a man who receives a beautiful antique watch as a gift. He cherishes it throughout his life, and on his deathbed, he gives it to his younger self. The question is, where did the watch originate? Who created it? This is the Bootstrap Paradox, a circuit in time without a discernible starting point. Another fascinating example of the Bootstrap Paradox can be seen in the sphere of information or knowledge. Suppose a time traveler learns a mathematical equation from a book written in the future. He then travels back in time and writes the original book with that equation. So, who actually discovered the equation? The Bootstrap Paradox flips our conventional understanding of cause and effect, forcing us to question the linear nature of time and the mechanics of our universe. It's a riddle that continues to baffle and intrigue physicists and philosophers alike. Next, we delve into the enigma of the twin paradox. This paradox examines the peculiar aftermath of a phenomenon known as time dilation. The concept manifests itself in a unique situation where one twin ages at a slower pace than the other, due to the effects of space travel. To better understand, imagine a pair of twins. One embarks on a journey through space, traveling near the speed of light, while the other remains on Earth. According to Einstein's theory of relativity, time moves slower for objects in motion compared to those at rest. Thus, the space-traveling twin would experience time at a slower rate. By the time he returns to Earth, he would be noticeably younger than his Earth-bound twin. This time dilation is not just a theoretical concept, but an observable fact validated by numerous experiments. The twin paradox is a brilliant demonstration of how the application of Einstein's theory of relativity can lead to some truly fascinating, yet confounding occurrences. Time dilation, as illustrated by this paradox, shows us that time is not as constant as our everyday experience might suggest, proving the universe truly is a place of wonder and complexity. Next on our list is the Ontological Paradox, a riveting concept that's sure to captivate your curiosity. The Ontological Paradox delves deep into the mysteries of self-fulfilling prophecies. These are intriguing phenomena where a prediction or expectation, simply by being made, sets in motion a series of events that cause the prediction to come true. It's as if the prediction is an active participant in shaping reality, not just a passive observer of it. Moving ahead, this paradox also grapples with the puzzling existence of objects or information that appear to have no clear origin. Imagine a piece of information or an object that is caught in a perpetual cycle of cause and effect, where the cause is as elusive as a shadow on a moonless night. Moreover, the ontological introduces us to the mind-bending concept of a causality loop. This is a sequence of events where the outcome of an event is actually the cause of that very event. With each cycle, the timeline is infinitely repeated, creating a never-ending loop. All these elements together form the crux of the ontological paradox, an enigma that challenges and stretches our very notions of existence and creation. Coming in at the midpoint of our catalog is the complex concept of the predestination paradox. This paradox, in its intricate nature, weaves together a scenario where the past, present, and future are so intricately interconnected that it becomes a challenge to pinpoint a distinct commencement point. Imagine a time loop where actions set in the future affect the past and vice versa, essentially negating the concept of cause and effect. This enigma, the predestination paradox, confounds our understanding of causality, spinning a web of uncertainty around the linear progression of time. This beguiling concept is bound to keep you on your toes as you grapple with understanding whether time is truly linear or a tightly knotted ball of yarn, leaving you questioning the very essence of time itself. Moving forward, we delve deeper into the intricacies of the Novikov self-consistency principle. This principle puts forth a captivating argument about the nature of time, stating that the timeline is more than just a mere record of events. It is a robust structure immune to alterations. This claim is grounded in the idea that any attempt to influence past events would inevitably lead to a closed causal loop. A closed causal loop is a sequence of events where the outcome of an event influences its very cause, thus creating a circular, self-reinforcing sequence of events with no clear beginning or end. This is a principle that the nature of time travel narratives, supplying a framework that prevents paradoxes and upholds the consistency of the timeline, no matter the external forces trying to alter it. It's a concept that questions, even challenges, our understanding of cause and effect, by suggesting that every event in time is interconnected and predestined, incapable of being altered or manipulated. Securing position number 7 on our countdown is the butterfly effect. Stemming from the broader chaos theory, the butterfly effect postulates that minute changes made in the past can have dramatically large and unforeseeable in the future. To illustrate this concept, consider a butterfly flapping its wings and setting molecules of air in motion, which move other molecules, eventually escalating into a chain of events that culminate in a storm happening miles away. This theory significantly challenges our perception of time travel and the control we believe we have over the outcomes. It suggests that even with the ability to go back in time, a seemingly insignificant alteration could set in motion a completely different future than intended, casting doubt on the very idea of manipulating the course of history. The butterfly effect introduces us to the uncontainable concept of chaos, a spontaneous and unpredictable order which reigns over our understanding of time. Chaos theory's implications run deep, affecting fields as diverse as meteorology, economics, philosophy, and even quantum physics. It represents an integral part of our exploration of the universe's most profound mysteries, the unpredictability of time and space. Coming in third place, we delve deeper into the enigmatic information paradox. This paradox poses an intriguing conundrum where information, once it crosses the event horizon of a whole, seemingly vanishes. This occurrence is contrary to the fundamental postulates of quantum mechanics, which dictate that information can never be outrightly destroyed. In essence, when matter is absorbed by a black hole, all traces of its original state, including its physical properties or information, apparently disappear. This suggests a permanent loss of information, a phenomenon that contradicts the law of quantum determinism. This law states that the information about a system at one point in time should determine its state at any other time. The information paradox not only questions the very fabric of reality, but also challenges our comprehensive understanding of physics. It pushes us to rethink our established theories and expand our horizons, making it a significant point of discussion in the world of astrophysics. Diving deep into the world of cosmic phenomena, we come across the intriguing white hole paradox. This paradox, second to last on our list, delves into the potential existence of the theoretical opposite of holes. Unlike the familiar black hole which endlessly pulls matter into a single point of infinite density, a white hole operates in a completely different manner. It is a cosmic object that spews out matter continuously, making it essentially impossible to enter. These theoretical entities arise from the equations of Einstein's general theory of relativity, just as their counterparts, black holes. More than just a paradox, the white hole paradox opens up a realm of possibilities for understanding time reversal and even time travel. These curious, hypothetical cosmic phenomena stand as a challenge to our comprehension of space-time, adding a fresh and fascinating perspective to our perception of the universe and its myriad mysteries. We conclude our journey with the Fermi Paradox, an intriguing conundrum that engages with one of the universe's most beguiling mysteries. This paradox delves into the puzzling question: why is it that, despite the unimaginable vastness of the universe, with its billions of stars and potentially habitable planets, we have yet to encounter extraterrestrial life? The Fermi Paradox doesn't just ponder upon the sheer scale of the cosmos, but ingeniously introduces the element of time into the equation. It contemplates that if there are a significant number of technologically advanced civilizations out there, then it would seem a reasonable assumption that we should have come some evidence of their existence by now. This paradox raises the perplexing possibility of the Great Silence, a term used to describe the deafening absence of extraterrestrial voices in our cosmic neighborhood. It stirs us to question our seemingly singular existence, thereby leaving us to contemplate our unique, perhaps even solitary place in the cosmos. With each passing day, as our search for cosmic companions continues, the Fermi Paradox leaves us with more questions than answers. And thus, we conclude our exploration of the top 10 mind-bending time travel paradoxes, each one serving as a profound testament to the fascinating, multi-layered complexity and enigmatic mystery of time travel. These paradoxes demonstrate the countless questions arise when we dare to leap beyond the constraints of linear time. Can we alter our past? Does the future already exist? These are questions that continue to both captivate our minds and challenge our understanding of reality. As we bid you farewell, we urge you to never stop questioning, to relentlessly pursue the thrill of discovery. Continue to ponder the bewildering mysteries of time travel and to entertain the limitless possibilities it presents. Who knows? Perhaps one day the concept of time traveling will do more than just exist in the realm of science fiction. Until we meet again, keep journeying through time in your imagination.